Greetings, students, and welcome to the first edition, and probably the only edition, of How to Use ArcGIS, hosted by me, your TA. What we're going to do today is I'm going to walk you through doing some of the basic things we did to start out on Lab 2. This is meant to just be a refresher of how to set up a map for your editing in future weeks. In ArcGIS or your future cartography endeavors. The first thing that we're going to need to do each week is obviously open up ArcMap, and you can see that I've already done that, as evidenced by the title here and this friendly layout, which you all know and love so well. The next thing we're going to need to do is actually start compiling the data that we're going to be using for that week. So that's best done in ArcCatalog, which I can access through this nice little tab over here on the right. From ArcCatalog, I want to make sure to connect to the folder where all our data is stored. And for you guys, this is, I believe, the data drive. You're going to find that under Computer. There will be one drive that is Data, and within that there will be a folder that is Courses in 188B. I'm not doing this on the GIS lab, so mine looks a little bit different, but I still have a folder called 188B, and the folder contains some similar stuff. So I'll connect to that and hope that you guys can make the translation to the GIS lab data storage policy. So it's going to show me the location of the folder that I'm making. This is basically a bookmark that ArcCatalog is going to use to quickly navigate me back to that folder location. So I'm going to push OK. The next thing you want to do is, if you do not already have a data storage location in your folder connections called, I believe, the Y drive for you guys. This is something on another external hard drive that is on the GIS lab server, where you can store data and where most of your default GIS data is stored. You want to go ahead and connect to that now. You can see I already have something called the Y drive here, so I'm just going to put all the files that we need into that. So for Lab 2, thanks to the glorious write-up made by my TA, I know that I'm going to need this file HCDEM. I'm going to need HC Hot Creek, a shape file of Hot Creek, and this file, a color digital orthoquad mosaic that my TA worked tirelessly into the night to create. I'm going to copy that first because it's the biggest one, and I'm going to paste it into my Y drive. Looks like it showed up there, so now I will go to the DEM, copy that, paste this, and this copying and pasting is just like the copy and pasting you would do in Windows Explorer, but there are 4 or 5 files associated with this Hilton Creek Hot Creek shapefile. So by dealing with this just in ArcCatalog, I can utilize the fact that ArcGIS software recognizes those 4 files as actually just one physical thing in ArcGIS. So now I have all those things. And I also know that I'm going to need to create a personal geodatabase, and I'm going to name that appropriately with the naming scheme we talked about in class the first week. And within that personal geodatabase, I'm going to need 2 feature classes. The first feature class I'm going to call HC Faults Me. The alias is your nickname for it, so I'll just call that faults, and we're mapping faults which intersect the surface as lines. So I will select line features. My coordinate system, as with all the coordinate systems we will use this class, I will find under projected UTM NAD 1983, and it is zone 11 north. If you think that is too time-consuming of a method, you can also use this import button here. Navigate to the file where your data is stored, select something you know to be in the right data frame, or excuse me, right projection frame, click Add, and you should see that that comes up there. Tolerance, the default will always be fine for us. Now, it says in my lab handout here that I'm going to need to add another attribute table that describes the confidence I have in my fault mapping for each particular new vector I add to my fault data line. So I will call that confidence, and I'm going to use a text-based system to identify these. You can also use a number, floats or numbers, long integers or numbers, short integers or numbers. These just allow you to do decimal places, while float is, float is a even integer. Alright, so that's all well and good. Length of 50 should be fine for the number of characters I can input, so I'll just hit finish there, and you can see I have that first fault, and it's added automatically to my layers here. Now I'm going to go in and add a new feature class again, and this is going to be Hilton Creek Offsets Me, and I'll call the alias offset moraines. Once again, this will be a line feature, and I don't really need to do anything special in here. I could do import again, but I like to be safe and just do it the old-fashioned way. No new fields are necessary, so I can just buzz through this. Alright, now I should have all the data I need. So I'm going to go ahead and start bringing this other data into my map. Just drag and drop somewhere into your map area. It may take a little bit of time, so you'll notice here that in my table of contents, the color raster has loaded, but it's nowhere in my map area. This is because these linear features got added to the map area first, and since nothing exists in those linear features, ArcGIS navigated me to some funky spot somewhere in the middle of nowhere. You can see down here that I am at some funky decimal degree location. So what I want to do is right-click that raster file and select Zoom to Layer. And that's going to bring me back to the familiar Owens Valley. Now, some of you may notice that this looks a little bit funky. And this is because when I started out, I defined a strange projection. And I did this just to show you guys that projections are an important effect. So it's always important to check what the projection assigned to your layers palette actually is. Now, this should be defined by the first file that you added, but I was sneaky, and before starting this recording, I manually changed the projection to something less useful. And we can tell that because, for one, the units are displaying in the bottom right in degree units, which are an angular unit, right, not a Cartesian unit. We could also go to coordinate system here, and you see how it says GCS North American 1983. That's not what we want. Also in there's one other way to look at this, I think. Here we go. In general, the default came up to this decimal degrees, so there's a variety of indicators that are telling me I picked the wrong thing. So let's fix that. Predefined UTM 1983 zone 11 north. That looks more like what I want to be seeing. I'll apply that. Select OK. It's going to take a second for that raster to refresh. Now it looks like that nice rectangular thing that we're all used to seeing. So let's go back and continue adding some more data. How about the DEM? And how about that Hot Creek shapefile? See it pop up there. So if we go to the table of contents here, this is something that's really important and I think people are missing out on. The table of contents just displays everything that's actually in your map document. If we are in this far left option, list by drawing order, the vertical order that they're in is sort of the stacking order. So if I take HC Hot Creek and I put it down at the bottom there, it suddenly disappears from my map, right? If I turn off these two features, you can see that it's definitely there, but because this DEM is on top of Hot Creek, and because the DEM is a solid thing, we can't actually see Hot Creek. Now, if I did something fancy, like go to Properties, go to Display, and add a bunch of transparency, I could start to see the creek through there, but you don't really want to do that. In general, you're going to want to make sure that your shape files are always on top of your raster files. So I'm going to stop the recording here real quick so this file doesn't get too big, and we'll resume in just a minute.